Okay, so we have our next presentation. Our next presenter is Mr. Fraser too, and his presentation is called Coding Myself Out of a Job. So let's welcome him with a round of applause.
Hello everybody, my name is Fraser too. So Coding Myself Out of a Job, interesting title. We'll get on to why I chose that title soon, but and that's fine. We'll just, I have to go over here and do that. Fantastic. Right, so I am from Scotland originally. Before I joined Chrysalis, I was a product owner at an IoT company in London, mainly working in the energy sector. And before that, I was working to design the energy use of buildings. So sustainability, energy is kind of a passion of mine. Before that, I started a KiWi band at university. This is a traditional Scottish music and dancing band where I played guitar, drums, and taught dancing. It's quite a turn-off of engineering, but it was good fun. And yeah, I joined Chrysalis to make useful stuff. I really like making things that people can use, and as a product owner, I always felt kind of bad, going and telling the developers, okay, off you go, solve this horrible problem, but I can't help you with it. And I wanted to sort of get more involved directly with software and sort of help to build the amazing cool stuff that we use every day. And apparently I've learned to juggle, which is something you can learn if you're at Chrysalis. So no demonstrations today, but it's good fun. My favourite questions to ask are, is it useful and is it usable? And today I kind of want to cover this general idea. The idea, a belief that I have. I believe that it's not going to be too long until you can create an entire web application without writing a single line of code. MVP, something basic, something prototype, front end, back end, the whole everything. It's not going to be very long until you can do it. So I'm going to talk a little bit about the problem that still faces this idea. I'm going to talk about some of the solutions and a little thing called Alwyn. And then the future of software development in general. So very grand topic, I guess. So has anyone heard this before? If you work in a software engineering company, maybe you've heard, our engineers aren't helpful. Or maybe you've heard something like, nothing ever gets done. Okay, obviously superlative, a bit over the top, but we hear it quite often if you're working in software development, because the people who are close to the customers, who have the ideas, who see the customers' pain points, aren't the ones who write code. So what happens is if someone has a great idea, they can't write code, so they have to usually enter something called a feature request. They put something into the development team, into the process. And but let's be honest, have we ever been at a company where there was plenty of time to work on good ideas? Well, no. Most of the time engineers are furiously working for a huge backlog of items. So the feature request, as good as it may be, will end up in the backlog. And perhaps an enterprising product developer, product manager will dig it out of the trash one day. But in most respects, and in a lot of companies, especially given if it's a small size, value can get lost in the mess of the backlog. Quite often that idea will maybe never even get to see the light of day. So we talk a lot in software about this idea of the minimum viable product. What is this mantra that small companies should follow, which is you should only build the thing that the customer needs. No more, absolutely no more. And it helps companies to focus and get stuff in front of customers and test it soon and early. Almost every company does this for their first MVP. And people do it because you can learn fast from customers, as the Lean Startup written by Eric Ries says. You can see whether small numbers, you can test the small numbers to see whether the big numbers, the big scalable, the big promises will ever materialize. We want to learn to solve the customer's problem. You learn by doing. Action is better. So we all think that MVPs are good ideas, but it generally tends to happen for the first idea for the company. The first big idea that the company has is the main MVP, and then after that, the product gets fleshed out. So all these other little MVPs become what I like to call MIPs, the most ignorable problems. So we want to be able to build basic MVPs, we want to get to know our customers, and therefore we don't waste energy and your time on stuff that hasn't been proven in the market. But what if you want this done faster? You've got this great idea, you think it's going to be good for customers, you want to put it in front of customers. How do you get it done faster? Well, right now we just tell people to go and learn to code. It's kind of become a bit of a meme, a bit of a catch-all term for developer handoff. It's just go do it yourself. We don't have time. And it's never been a better time to learn to code. I would say if you're thinking about learning to code, start now, because there's some amazing stuff out there. I've just listed some of the free options. Free Code Camp is one of my favorites, but they freely admit that it will take you hundreds of hours to get to a point of where you can actually build something you can put in front of people. It's a long process to learn to build production-ready stuff that you can put in front of people and be proud of. So my journey is a bit of an example of that. I've been engaged with software since university. I was taught Python, but all I was really doing was, building basic stuff, building little prototypes to pass my classes. Maybe at the IoT company, as a product manager, I built bash scripts because I couldn't be bothered telnetting into hundreds of devices. I only learned the bits I needed, and it's only once I've come to Code Chrysalis, to a full bootcamp, 6 weeks in, I was actually, I can actually put something in front of customers now. I know how all the processes go together. I know how to do it. But it takes a long time. You're only solving current problems. Most people have a lack of time to work on anything that isn't their job. So they don't have time to learn to code or even write code. The learning process might exceed the length of the idea, hundreds of hours. Well, once you've done all that work, your idea becomes maybe irrelevant or the market has moved on. So you've missed the opportunity. Obviously, if you learn to code initially, you're going to write a lot of bad code. It's part of the learning process. But the senior engineers don't like to see bad code in the company. They want to control all the code. So it kind of, it's a natural part of the process. And also testing, a mark of a young developer is they don't write a lot of unit tests. And it's because it's something that's generally not taught in free coding courses and lessons, is they don't get taught how to test. It's this other thing, it's other process. Despite the fact that, let's be honest, testing as a concept isn't a horrendously difficult idea. It's if input is X, output should be Y. But it's just this other framework that gets bogged down in the mess of trying to do everything else and get something working. So what we want is something that's quick to use, it's easy to learn, developer-defined code. What I mean by that is that you can write in code that the rest of your company uses so that people can pick up where you left off. And also, we should enforce tests because we get lazy, we don't write tests, but I think TDD is great, writing tests is great, and it means you can scale the application, you can write the application into the future a lot easier. So there's this innovation gap, I would say, where if you want to, between waiting and completely learning to code yourself, there is nothing in the middle. There is no halfway house to building something useful. There is a big gap. So what do we need? Maybe we need a better language, maybe we need a better framework. So what currently fills the gap? Well, if we look at Stack Overflow, if we believe Stack Overflow's survey, you can extrapolate it to roughly 50 million people in the world can use JavaScript. But there is a programming language that currently fills this gap of innovation that is used by far more people in the world. Has anybody ever seen something built in their company using Excel? People like Excel because you can do this in 2 clicks. Something good, you can put in a presentation, show it to your boss, 2 clicks, no more work. It's fantastic for what it does. But then stuff happens like this. So your simple becomes horrendous complexity. I built this monstrosity to test grid scale batteries. It's got 300,000 calculations. I'm very proud of it, and I'm also very ashamed of it. But it took 3 minutes to run. Opening it on my laptop, it would manually do all the calculations again. Excel's really inefficient. So it took ages. You have to copy paste in the data, and all it really gave you was a yes/no output. You can't connect it to other systems in any meaningful way. I learned Python. It ran in 5 seconds. I went through the whole object-oriented process. I wrote tests. It was structured. It was easy to edit. I turned it into an API. But people stick with Excel because it's visual. You can start simple, and then you can make it more complex without too much work. You can sort of iteratively increase complexity. Whereas Python is not visual at all. It is complex from the beginning. You need to go through a whole process of learning how computer languages work, learning core concepts before you can even start. Maybe you can use online tutorials, but maybe you just don't understand what's going on. Excel is straightforward. So I'm not advocating to use Excel, but what we want is something that's visual. You can start simple, build towards complexity, because everyone likes free stuff. Maybe open source would be a good way to go. So I don't know if you've ever heard of visual programming. Maybe you've heard of some tools here and there. And actually, it's kind of a bit like climate change, because in front-end development, you can now build a basic website without writing a line of code. And it's getting increasingly towards the complicated elements of front-end design. Figma now compiles down to WebAssembly. I don't know if anyone's familiar with what WebAssembly could do for front-end development. It's much faster web applications. I was looking at Webflow the other day. You can build stuff that's very responsive, very clever, much more clever than what you can maybe build in something like WordPress. Things are moving along. It's maybe not going to be very long for front-end development until these are the major tools to start building a website. So let's look at the stuff that's back-end. that's where the real gap lies, I think. So here is a completely non-exhaustive list of some of the visual editors out there. So I'm just going to go through them in turn. Tableau and Niagara. So Tableau is a data science platform. It's quite easy to visually create data science applications, and Niagara is mainly used for building management systems, so you can drag and drop in how your building is supposed to operate, all the heating and cooling, but they cost masses of money, so not open source. We're going to get rid of those. You can't use them in your own company very easily without paying people lots of money. So Unreal Engine, that's a game engine, and they've got this really clever thing called Blueprints, which is a visual flowchart coding editor that you can compile down to C. It was built so visual artists could turn their animations into something in the game. It's really great, but it's really locked into games, and there's a lot of visual editors are like this, where they're not what I would call generalized. They don't apply to lots of different situations, they only apply to one. And Unreal Engine, while it's pretty clever, and while you can do a lot of good stuff with it, you can't take it out of Unreal Engine, it's stuck there. And you can't build anything that's not a game. So we're going to get rid of that. So what we're left with is Blockly by Google, which is what Scratch is based on. It's like a fork of Blockly. And Node-RED, which is part of the Node.js framework, and it's maintained by IBM. So looking at Node-RED, it's one of my favorite ones. It's what you might call event-driven, so thing happens, then thing happens. So we just look at this thing that I built in 5 minutes. Every half hour, we're going to get some information from a web source. We're going to turn it into something we can use, and then if it's above 300, we can print the output. Very simple. You can build an API in 5 minutes. Great UI. Drag and drop, clickety-clickety, done. But you cannot export it to code. It's kind of inefficient. You have to run it within its own runtime. So if you want to turn this into code and give it to a developer, can't. They've got to completely start from scratch. So that's kind of a shame. It also doesn't have tests. Blockly can export to code. So it's more of what I would maybe call object-driven, so you kind of build functions rather than connect them together. So it exports directly to code. So you see this kind of counting the number of times of hello world, immediately flips over to a JavaScript version of the code. So that's pretty cool. You can make something visual and turn it into code, but it's kind of basic. It's, maybe you've used Scratch before, it's very boiled down. It's kind of hard to add new blocks. I actually tried to use this at first to adapt Blockly, but it was kind of weird to kind of change the libraries. And fundamentally, I feel the UI is weird. The way you think about the code is weird. I don't know if this makes sense to many people immediately, but if you look, comparing it to Node-RED, which is very visually, I immediately see what's going on. Blockly, it's a bit like, it's weird, blocks connecting inside other blocks and wrappings and whatnot. It's a bit hard to really get your head around. So a bad UI with Blockly and no external libraries, and then with Node-RED, it's performance limited and no export. And both of them have no testing and are kind of weird to adapt. It's not easy to just fork it and add the bits I want and adapt it to my own business logic. I'm locked into whatever they've decided should be done. So it doesn't mean we can't solve this problem, going back to the lean startup. We want to be bottoms up, decentralized. So how about we try and solve this problem? We're engineers, so we want something that can export to code, defined code by engineers, uses the same language that you use in your organization. We want something that's got a great UI, like Node-RED, and has libraries, community support. And then we want testing, because everyone likes tests, and we want maybe something like single file adaption, which is where in order to add a new block, there's not some mess of running around several different files editing stuff. You just want one big file that defines the entire new block. So I built something called Alwyn. I built this in 2 days to prove almost that this problem isn't hard to solve. It just hasn't been solved yet. It takes a flowchart and turns it into code. It supports tests natively, as it were. I built tests as the third block I made. And the code is defined underneath the block, so you can just change a little string that changes what the code actually says. Instead of using chai, you could use a completely different testing library, whatever you liked. So I'm just going to go over to a quick demo, so hopefully this doesn't blow everything up. Okay, fantastic. Right, so I've already put, here is Alwyn here. You can click on the blocks, you can kind of move them around. So I'm going to add a new constant block. I'm going to call it, I don't know, Dustin, because he's sitting right there. What's Dustin equal? Dustin, I can't make it equal, well I can make it, Dustin equals wonderful. So that's nice. So then, I know I can't sum wonderful, okay, right, whatever, but let's say I wanted to do this, and then I make an assertion block, so x should be equal to y, and because JavaScript is insane, I can say expected, I'm just calling the block something, and then let's call it, because JavaScript is completely insane, it's probably going to be one wonderful, right? So, fantastic. Now, this doesn't run on the Node backend yet, I haven't kind of hooked that all together, but when you click what is the code, turns it into code. So there's your requires in the assertions, there's variable x defined, there's Dustin defined, there's my expected output, there's the sum, and then my assert equal test sum equals expected. So that didn't take long to build, and it's already kind of most of the way to what I think would be a good way of working things. So I'm just going to swap that presentation. Okay, so imagine something like this, deployed into a company's business logic. You can define your own blocks. Maybe you allow people to, I don't know, talk to external APIs. Maybe you build you're a dashboarding company. You want to build personal data dashboards. Your salespeople could find out that someone wants to get Bing News instead of Google News. You could just knock something up in Alwyn in 5 minutes with some defined blocks. It could immediately be deployed to cloud functions, Lambda functions, small little snippets of APIs on kind of cloud-based talkative stuff. I won't go into APIs, but, and then it immediately hooks into something built in the front end. Maybe you talk to some other services in the cloud. Fantastic. Maybe you can use it as configuration. So one problem we had at the IoT company was they had this energy control device. But every single energy device has a different configuration and needs to be talked to in a different way. So every time the developers need to write an if. So if it's this kind of thing, then we do this. If it's this kind of thing, then we do this. But what if we had Alwyn as a way of making configuration? Oh, well, actually, we can define how to talk to any object. The engineer on site can just use a little flowchart Alwyn style thing to live adapt to a new product instead of having to do it back in the lab and deploy it as part of our general deployment procedure. So it's an interesting idea. Instead of horrendous drop-down menus that are just completely undecipherable, you could use something like a flowchart editor. So let's think about the project flow now that we've got it. You have an idea. Maybe you talk to some people around the company, form your idea into something sensible. You spend some time with Alwyn, and then once it's ready and all the tests are passing, you put it in front of some customers. Maybe they like it, maybe they hate it. But now, if they like it, then you can pass it on to developers, and developers can do what developers do and make it nice and fast and efficient. So I want to just finish off with the question of, do we really need Alwyn? Do we need this? Well, we don't need my thing specifically, but we need faster prototyping. And we need user-defined features, because people will fill the gap with Excel if we don't give them these tools. We want to give people power. We want to give people the ability to solve their own problems so we don't have to solve them for them and waste loads of time in doing it. So aren't we coding ourselves out of a job? If I just give everybody the tools to develop everything, what's left for me to do? Well, imagine you only ever had to work on an idea that was already proven to work. I don't know if many people work in startups, but at the start of a startup, it's complete risk. You're building something you don't know is going to pan out. People put their lives on hold, money on the line. If something was buildable in the prototype, like a more fully fledged application, you could try it out, see if people want this thing, before you spend a lot of engineer time and money trying to make it into a full product. So developers act like now like the magic magician, gatewaying access to the magic Pandora's box. And maybe your application is a lot like that. But I think we need to be, instead of developing in the traditional manner, I think we need to develop more collaboratively. If we put more power into the hands of the people we work with, developers don't need to do all the work, but people want to do work. Other people in the company who work in tech companies, they like tech, they like your product, they want to make it better, they're passionate, they know what the product does and what it should do. And if you give them a little more say in the process, a little more access to the process, I think you can develop some real value in companies. I just think it would be a great idea. So thank you very much for my talk. The photo up at the right hand side is Alwyn. That is with my grandfather Alwyn, who was a university professor who I named this after. So if you're interested in this idea and this open source project, there's a repository there. You can go have a look at it. I'm really keen to work more on it if people think it's valuable. I am Fraser Tooth everywhere, and you can find my silly little website on frasertooth.github.io. So thank you very much for listening, and chat to me afterwards.
Thank you very much. So our next talk is going to start at 2 p.m. So we're going to take another short break. Additional housekeeping. So we don't have Q&A sessions right after people's presentations. So if you have any questions, feel free to go up to the person who presented. We're always excited to talk to new people. So feel free to do that. So let's come back at 2 o'clock. Thank you.